Hello, so I'll show you how I use Houdini to transform my particle fluid data into a nice mesh. So first of all, my data is here, so I have a bunch of frames, 400 frames here, of a fluid simulation. And for each of these frames, I have a list of particles that compose this frame. So here I have 80,000 particles, and for each particle I have some index, then I have a 3D position, I have a 3D velocity, and I have some integer flag. The only thing I'll care about here is the 3D position. That's all I need to create my mesh. And so this is how my data is formatted, but your data could be formatted in any way you want, as long as you're able to read the position. Okay, so in Houdini, what I'll do is press Tab, go to Geometry, and create a geometry node. Creates a cube by default, but if I double click on it and I delete this node here, you see the geometry disappears and I now have an empty geometry node. So first of all, what I want to do is I want to import my particle data into Houdini. So I'll create a custom node for that. So I'll go to File and then New Operator Type. I want it to be a Python node. I want it to be inside a geometry. I'll call it import particle 2, but you can call it whatever you want. Import particle here, and that's it. Accept. Now this window will pop up, which has everything you want. Basically, number of inputs. In my case, I have none, because I'll be importing everything from an external source. In parameters, I want to have a string so that I can tell Houdini where my data is, so I'll call that file path, like this. Oops. And then the important part is here in code. So you can put any Python code you want, basically, and Houdini has all the nice functions that you would need in this who dot something, which you can Google. The documentation is pretty thorough. So I already made the codes for that. So for my importer, the code is right here. So what I have, first line is who dot current node. That gives me the node, and then geo, it just extracts the geometry from this node. Right now the geometry is empty, but we'll add geometry to that. And then I'm querying what is the current frame of the animation. You see I have this sliding bar here, which says 1 right now, so I'm at the first frame. So who.frame will give me this number, which is a float, so I'm turning it into an integer. And then the file path that I'll be using, I'm just querying this parameter that I just set. So who.currentNode.evaluate parameter called file path. So that's just a string that will point towards the directory where my data is. And then f will be the file that I open as the directory plus the name of my files times the number. So if I go back to the way my files look like, it's all parts underscore 0000, then 00001, etc. So this will give me the 000 something dot text, and I'm opening this for reading. Now if you'll notice in my files, I first have a couple of lines here that I don't care about. So 1, 2, 3, I want to start reading at the 4th line, so I'm 1, 2, 3, 4 lines right here. And then as long as my line is not empty, I'm reading the line and I'm processing it. So so the line variable here is my line. I'm splitting it, storing it into SL, and then I extract the positions 1, 2, and 3. So by default, split will split it with white spaces, but you could split it with whatever your separator is in your format. So 1, 2, 3 in my case corresponds to those 3 guys, which is the X, Y, Z position. So I'm storing this in variables X, Y, Z. And then I'm creating a point using those coordinates. So this point is equal to geometry dot create point. So this is just a function in Houdini, and geo here is the geometry that I took from this node. And then this point I'm setting its position to the XYZ coordinates I have. And then I read the next line and I loop. And when I'm done, I just close the file. Okay, pretty simple. So if I go apply and then accept to close the window, then I can just create this node. Here I'm in my empty geometry node. So if I go back to the object level, I can see my node, and if I double click on it, I enter it inside the node. So if I hit tab, then in digital assets, you'll see I have this import particle operator that I just created. So I'll just take it, put it there. And right now it's complaining, so if I hold the middle mouse button over it and I look at the last line, it'll tell me what the problem is. So here it says no such file or directory, blah blah blah. So of course, because if I look at, let me just put this a bit bigger. If I look at, when I click on my operator, if I look at this parameter here, the file path is not set, so I have to set it myself. So I'll just go into Windows, copy the path, and put it right here. I'm not sure, but I think I have to reverse those slashes. I'll do it anyway. It's always safer to have forward slashes. There you go. Okay, so now I have my path, and you see now the node is not complaining anymore. And if I look in the window here, all my data is imported. So if I hold Alt and then scroll back, I'll have a better view of the scene. So there you go. So my data, the first frame is 2 big blobs of water falling inside of a pool. And now the cool thing is, because in the code, if I go back to the code, so I right click on the node, type properties, sorry. Because I'm using this who.frame here to select what file I'm opening, if I move the scroller, you'll see that different frames of my animation actually get loaded. So first of all, I can visualize this animation just to make sure it has everything I want. And I said previously that I have 400 frames, so I'll just go here. If you click on the last item here, you can set the maximum frame, so I'll go to 399. There you go, apply. Yes, I want to stretch the channels. There you go. So now I can just look at all of my frames. Okay, that's good. Now how do I create a mesh out of this? In Houdini we can use a bunch of already created nodes, and some of them are VDB that create a volume out of points. So if I hit tab again, I go into VDB. I want to take VDB from particle fluids. Be careful not to take VDB from particles. That will create a very non-smooth structure. You really want to create it from particle fluids, which use something that's like metaballs-ish. Okay, so I'll just put it there. Okay, and then I'll just link my imported geometry inside VDB, and then I'll click here to show the volume. And you see now it's taking forever. You can see if you look at the timer here, it's showing you how long it's been computing it, and that is way too long for my taste. So I'll just spam escape until it stops computing, and I'll look at the VDB. In VDB I have this particle separation attribute here, which 0.1 might be way too small. So what I always do is I start with big values. You see it creates a very, very coarse mesh, very ugly mesh, but then I can refine and figure out what is the size that I want. Okay, getting there. Okay, maybe 1 is okay for now. So you see the volume kind of matches my data. If I go back and forth, you see that it kind of matches it. But a volume, it's not what I want. I want a mesh. So tab again. I'll just tab, and I can directly type in the search bar I want to have a mesh. That's not it. I wanna have VDB. I think it's called convert or transform VDB. Convert VDB. There you go. So here I have the option convert to a polygons. That's what I want. So again, I'll plug the volume inside this first input. If I middle click this input, it says VDBs to convert. That's what I want. And the others are optional reference surface. I don't care. And optional VDB masks. I don't care about that either right now. And now if I show this node, you see I get really a mesh. But now it's quads, so I'd like to have triangles. So what I'll do is just hit tab again. I think there's something called remesh. Yep. So I'll put a remesh node again. This is the geometry to divide, and this is reference for edge length. So what I want is to plug this volume inside the first input, and then I'll be careful with the target edge length. Again, I'll put it quite large for now. Then I'll show this mesh. You see now I have nice quads, and it's actually quite nice. 1 seems to do it. If I go to 2, now it's too coarse. 1 is better, and if I go to 0.5, yeah, okay, it's a bit finer. I'll leave it at 0.5, I think. Of course, you can play with that. If you're, I think my data was all in a 0 by 32 by 32 by 32 box. So if your data is smaller, those numbers for the target edge length and also in the volume for the particle separation, they have to be adjusted. So yeah, now I have my mesh. And again, if I just move that slider here, of course now it's a bit slower, but because it has to create the mesh. But I still get 1 mesh per frame. That's pretty cool. It's a bit too coarse for my taste, so I'll play with it a little bit. If I go into the VDB volume, particle separation is pretty important, so I'll move it to 0.75 so that it gets so the smaller it is, the closer it is to your particles, and you can play with those other parameters. So okay, let's say that's fine. Okay, so now that I have my mesh, I want to export it. So what I'll do is I'll create another custom node, which will now be an exporter. So there you go. So I'll go in new operator type. This one will be called export mesh with label export mesh. It will be a Python type, again in geometry, accept. So I get again this nice window. Oh, it opened it twice, not quite sure why, and I'm not sure which window is which. So what I'll do is I'll come here, press tab, go into digital asset, put in my export mesh node, and then right click it, type properties, and there you go. Now I'm sure it's the right window. So what do I want in here? I have 1 input, which will be the mesh, and so minimum 1, maximum 1. If I go in parameters, I again want to have a string so that I can tell my exporter node where to put those meshes. So again, I'll call it file path with label file path. Okay, and then if I go to the code, again, I've already written the code for that. So let me just copy paste it. Okay, so let's see at what this code is doing now. Again, importing the node, the geometry of the node, and then the faces of the node. So that's geometry.prims, prims for primitives, and in this case it's a mesh, so the primitives are faces. I'm again using the frame number. The path, I'm taking it from the parameter that I just set up, and I'm opening the file. Now I'm opening a file for writing, so this will really be my output file. And again, I'm opening it at the file path directory, and I'm calling it something. In this case, I'm calling it mesh underscore, again, the number of the frame with 40 padding. And then what does it do? For every faces in faces, okay, so it takes the 3 vertices for each face, and it outputs it to a file. So what I'm doing here is I'm creating an OBJ file, but again, you could use this data to create any output data that you want. It's just OBJ files are easy to write. Okay, so for the first vertex, I say vertex is equal to face dot position at 2/3. So the way vertices are stored in faces, they're really stored as a loop. So position, it's a loop from 0, and then it loops back onto itself at 1. So let's actually make this way clearer. So this is how it's done. You have your face, and here you have 0, that'll be 1/3, 2/3, and then it loops back to 1 here. So what I want to access is really this loop at position 0, 1/3, and 2/3. And I go in the reverse order actually because of face orientation. For OBJ files, it has to be in the clockwise order, and for some reason Houdini stores it in the other way. So that's why I start at 2/3, and then I'll go at 1/3, and then 0. And so this vertex is really just a point. It's really just a position, so I can extract the x, y, z coordinates by just taking vertex 0, vertex 1, and vertex 2. And then I'll just write this into the file. So the OBJ format is v for vertex, and then you write the 3 positions next line. So I do this for the 3 vertices, and when I have my list of vertices, then I want to write the list of faces. So here I've been a bit sloppy. What I'm outputting is not actually a very clean mesh, it's more of a triangle soup. So each face will have its own vertices, which is usually fine for rendering, but you can use other tools if you want to merge those duplicate vertices together to have a cleaner mesh. So what this code here does basically is it'll just output f1, 2, 3, f4, 5, 6, f7, 8, 9, etc. And then I'll just close the file. This format will be clearer when we look at the output actually. So if I just hit apply here, and actually accept, if you hit apply, it doesn't close the window. If you hit accept, it does close the window. And then before linking my mesh into this new node, I'll put the file path. So I want to output the mesh, maybe not in the same folder. I'll put them like one level below, maybe somewhere around here. Again, I'll switch those slashes just to make sure. I've had problems with that in the past, so don't want to take any chances. There you go. So now I think I'm ready to connect my output mesh to my export node. Then I'll show this node here. And is it doing something? Yes, you see it outputted an OBJ file. So I can open it with, say, Notepad. So I get a bunch of V, then XYZ positions, and at some point it'll switch to faces. There you go. So that's what I meant. It's really just saying F 901, 902, 903, and then it just increments it like this because each face has its own vertex. It's really just like grouping each group of 3 vertex together. So nothing fancy, but still I can I have a mesh. So if I use something like say Mesh Lab to look at the mesh, take this mesh, drag and drop. Here you go. Here's your mesh. So you see here it's a bit rough. It doesn't have much polygon, so I could play with the parameters in Houdini to have more polygons and maybe make it a bit smoother. Actually, if you go look at the parameters, if you want to have more triangles, the target edge length is what you want to play with. If I put it to 0.4, you see I should get more triangles. Yes. And if this mesh is still too rough for your taste, in the remesh node you have this smoothing parameter. So if I put it to 1 instead of 0, you'll see that it does smooth the mesh. But then it really depends on what kind of look you want to have for your mesh and what you want to use it for. Alright, so everything is set up. Now the very useful thing is that we can process all of our frames at once. Again, I wanted to go to 1, it went to 2, so I'll just spam escape so that it stops. Whoops. Oh, it finished before I pressed escape. Anyway. Okay, now it's going to 1. I'll just let it load. Alright, so this is the mesh for my first frame. And now I can, first thing you want to go right here and say play once, or else it's going to loop forever, and you don't want that. And now if I just hit play, and I'll jump in time right here. Okay, so here I waited a couple of seconds. You see it's still processing my frames, but now if I go look in the folder, I get a series of meshes for up until frame 45, and if I wait long enough, I'll get all the meshes for all of my frames. So you can just let it run, and once it hits the end, it'll just stop. So that's it. That's how I mesh my particle data inside of Houdini. Hopefully that was helpful, and thank you.